Hi everyone. Am I audible? Yes or no? Am I audible? Yeah. Please let me know. Yes. Okay. I think other half of the class is missing. So we'll start. We will quickly revise rather than waiting because we'll start with a revision kind of thing every day. Yeah. So yesterday's class we have studied about in yesterday's class transponders. We studied about transponders, how they are used in communication satellites, their importance in communication satellites, uplink and downlink frequencies. It's a kind of amplification is done by transponders. Then we saw different bands also with respect to satellite frequencies. See, varieties of frequencies will be there. 30 kilohertz, 300 kilohertz, different applications will be in different frequencies. Okay. Whereas satellite or microwave telecommunications are generally used in this band. So in that also different parts are named as different names. L, S, C, X, K, U, K, like that. Okay. So like that it has been done. Now, in this context, we saw that each band will have different applications. Each band will be used for different applications. That applications also we saw very briefly. Why this is named as 1 to 2 gigahertz, why it is named as L, 2 to 4, why it is named as S, you leave all those. So at the max, they will ask applications only. L band used for positioning systems, global positioning systems, or regional positioning systems like that. C band for cable TV, TV network, satellite TV kind of thing, big dish. We saw the difference between two antennas here. Okay, which now among C band and KU band, if antenna size is less, which thing will be in higher frequencies? Which will have very high frequencies here? Answer. Now it is more number of things we can ask now. KU band has higher frequencies. High frequency, low. Exactly. Very good. So that is the way we saw this example here yesterday also. We related with this TV example also. Cable TV, then and now kind of thing. So different bands and different applications also we saw. We saw the concept of triangulation. Okay, how you can know the position. Minimum 3 satellites are required. If you have a 4th satellite also, you will have altitude also, at what height you are standing. Okay, on a mountain or on a hill or on a valley, all these things. So this is PTS. GLONASS is GPS for Russia, Galileo, European Union, BidU, Quasi-Zenith, and India's own Navik. We saw India's own Navik has both varieties, restricted service and standard positioning service. This is only for authorized personnel only. Okay, so more accuracy also it will have. So various applications of regional navigation system. This is very important. Any 2 or 3 things will be asked and multiple questions can be asked. So the accuracy of our IRNS is 20 meters. We saw how our 7 satellites are located. 3 in one orbit, 4 in geosynchronous, 3 in geostationary orbit. So the area is 1500 kilometers around Indian boundary. Okay, that is the way which we are going. These are the things which we are doing here. Now, there is another thing. We'll start with space capsule recovery. So this is very important for fulfilling human space flight, human missions. So this kind of experiment is very important for carrying out human space missions. Okay, when I call human missions, I was referring to space missions only. Okay, so space capsule recovery means, see, they have sent this already. This experiment is done. In fact, long back they have done, but still we are working on many things. In this rocket, PSLV rocket only took this thing with many other satellites. They left this capsule in the space. It has rotated in the orbit for 12 days. After rotating in the orbit for 12 days, it has to come back. It came back. Okay, so this and we recovered it in an experimental manner from the sea. We recovered it. It come well with parachute deployment and all those things. Okay, re-entry in the atmosphere. It should not burn because atmosphere will have lot of burning on the outer side. A lot of friction will be there, air friction and all those things. Okay, so that's the manner it was able to do. So we saw two things: reusable launch vehicle, as well as this is second one, space capsule recovery. Okay, because something like there is Earth. Okay, there is satellites rotating around the Earth. This is the satellite. Okay, till now we don't have a concept of we means we are talking about our own India's program. This satellite coming back, have you heard like this? Collect the data and coming back, it never happens. It is gone because satellites will only have solar panels. It will not have engine reboosting, nothing it will have. Okay, it will rotate after its lifetime, it is discarded. Okay, it will still remain there only, what it will do. Okay, so it is returning. In the same manner, astronauts also can return through this space capsule recovery experiment. That's what we are able to do it in a experimental manner. ISRO was able to do it, and weighing this. Look at the weight of this capsule, almost 555 kg. Okay, in 2007 itself we saw. So this is a very deep it takes, sir. In 2007 we did this. Why not no human space flight? Because we know now our priority is not this. Okay, we are experimenting. If this becomes our priority, we might have focused it in a very high manner on this. Our priority is always space applications. Okay, so now we are focusing Chandrayaan 1, Chandrayaan 2, MOM, all these things. We are now focusing on Gaganyaan, which is nothing but human space mission. Okay, so yeah, so that's what we are looking at. So all these things, see, today we will see after apart from the space, tomorrow, maybe in the next class, may not be tomorrow. Tomorrow we will not have a class. If possible, yeah, not if possible, we'll make it. Tomorrow there will not be class. Revise whatever is done till now. Okay, in the next class, we will have an examination. I will display the questions. Okay, so concentrate. Many new things will be knowing today. Now, coming back to another brief things. All these things are being developed in the Indian space program. Okay, so this is next theme is air breathing propulsion. So in the previous section also, what is space capsule recovery? That you have to know. What is its purpose? How is it important for human space mission like that? So next thing is air breathing propulsion. This is a new area. All the latest developments we are looking at. Air breathing propulsion means, see, the rockets which we have, whether you have PSLV and all those things, they have engines and fuels. The fuel is burning in the engine. How burning will happen? Fuel has to burn, right? So it is nothing but burning is called combustion. The combustion will happen only with the help of this. When oxygen is there, then only combustion can happen generally. Okay, so anyway, it is oxygen is required for combustion. Now, our atmosphere, if you take Earth, our atmosphere till see, the satellite will go above it, no doubt. But till the time it is going, our atmosphere is full of oxygen. Yes or no? So why can't we use the oxygen present in the atmosphere itself rather than carrying it? That is the idea behind developing air breathing propulsion systems. Okay, so not only while going, while re-entry also. So like that in the previous thing we saw, recovery experiment, re-entry also will happen. In this, it will re-enter. So like this, re-entry. When it is entering also, if fuel is required, anyway, basic fuel will be there. The burning combustion can take place from the oxygen which is present in the air itself. Okay, when the capsule is entering, that's what we are talking about. Okay, when the capsule is returning, it can take the oxygen, it is returning. It can take the oxygen present in the atmosphere itself rather than carrying it. So that is the idea behind developing these kind of engines. So launch vehicles, they will see how it is going. It will suck air breathing. It will suck the air, which has, obviously, it has oxygen. Then inside fuel will be there, combustion will happen. Then after combustion, energy will be released, exhaust also will happen. So in this direction, the aircraft is moving or the rocket is moving in this direction. As it goes, it breathes the air, uses it for burning and releases. Because of it, it will go more faster. Okay. Now see, when we are using the thing which is already in the air, obviously the fuel load will decrease. Yes or no? If weight of fuel is decreasing, the payload, more amount of satellites or satellite weight can be carried easily. So like that. That is the purpose of this air breathing propulsion system. So this is a new kind of engine design. So we are using up to 50 kilometers. 50 kilometers of Earth surface has enough amount of oxygen. That's the reason we are relying it, at least while going or while enter, so that it will become the aircraft or the space launch vehicle will become much lighter and cost effective also. Okay, this reusable launch vehicles also can use this air breathing propulsion systems. So that is the advantage of air breathing propulsion. Any doubt in air breathing propulsion? Any doubt in air breathing propulsion? Okay, bahut badhiya. Right? Then we are going to our next theme. Understand these things because I will put questions on this area in a twisted manner. Something extra also I will put. So based on that, we will practice. Fine. Next thing is a very important example here, Astrosat. India's own mission. Yeah, definitely. See, it's not like air breathing. All these engines are kind of air breathing only, but this is the basic on which all these are made out. Scramjet will subsonic, supersonic speeds. The combustion should take place at supersonic speeds. So that is the thing that definitely we can relate it to them, no doubt. Now, Astrosat is India's mission, India's observatory. Astrosat, it's not there. We will use after 50 kilometers, there will not be any oxygen. Nah? So it will have its own fuel later. That will kick in. We are carrying the oxygen. Okay. So at least till 50 kilometers, we can use it Volga. That is the intention. Okay, because the gravity will be very high when we are nearer to the earth. So more amount of energy is required. That's the reason we are relying on all these methods. Okay? Chale aage? Fine. Now, just a minute. Yeah. बहुत बढ़िया. अब देखेंगे. So this mission speciality we have to understand. India's own Astrosat mission. So this is Indian astronomical mission. It is there. See, where we want to observe space. Space mission is about doing something with space. Now, when we want to observe the space, rather than having a telescope here, what if there is an observatory in the orbit around Earth? The observatory is directly here, looking into the space, rotating around the Earth. So that is the India's own astronomical mission. The very specialty why we have focused on this is it has all the three measurements: X-ray, optical, and UV spectral bands. Say you may feel it has something very new, but what is happening here is the mission is able to get images in all the three spectral bands. See, when you are a kid, you might in Discovery Channel, you might have seen that some animals will be able to see during night. How in the night? Because eyes can't see, but how they are able to see? Because they will be using IR wavelength. So imaging is not only visible light. Visible light means what we are visible to this, but the light energy or the electromagnetic energy in different forms, cosmic rays, radio waves. We are not seeing all of them. No? Similarly, we can make images out of X-rays. Optical means the visible thing, which are, and UV. Astrosat will collect images in all the three bands. That is the speciality of this mission, which is important. Okay. So all the three spectral bands, it will have images. So we can collect more data. So that is what uniqueness of our astrosat method. Simultaneous multi-wavelength observations can be done. So more better images can be produced. So look at the objectives of astrosat here. Look at the objectives. Just read this. Importance of this is the importance of astrosat mission. What all things to understand how binary star. Binary star means a star will be rotating against another star. How can we say that around star only planets will be rotating? Okay, sun and other planets. That may not be the case. Na? In the universe, many beautiful things are there. Many things are there which we can't understand. Yes, there is a bigger star, there is a smaller star. A star will be rotating against a bigger star. This is called binary star system. Neutron stars, black holes, all these things we will discuss in the life cycle of a star. Maybe in the next class, because you understand this only, we can understand something about astronomy. Okay, one thing you understand about black holes. What are black holes? Black holes means is a huge dense body object, okay, out of which even light also can't escape. The gravity is so high in this black hole, it will suck everything, even light also can't escape this object. So much of density it will have. So that is called, that's the reason it is called black hole, because we are unable to see it. Then how we are identifying black holes, sir? Because light, everything is at the edge, there will be a bending. Only the surface of the black hole we are able to observe. That's the reason only that we are able to see that there is black hole inside it. It will just suck everything. It will suck mass, rocks, everything. Even light also can't come out clearly. So this is a phenomenon called black hole. So around the black hole also stars will rotate, neutron stars will locate, all these things. So we can study all these phenomena, new sources, bright X-ray sources, survey of the universe in ultraviolet region. These are all the advantages of astrosat mission. Okay, so black hole is very important. We will see that in detail later. Okay, so one thing is in news in recent times is reforms in space sector. Reforms in space sector. What are the reforms we are going in the context of privatization? We are opening up the privatized space sector for privatization. Previously, all the rocket launches are done by ISRO. ISRO will outsource it to some companies, maybe, but ultimately it is ISRO which will take a final call. Okay, so when the world, like if you have heard about SpaceX in USA, it is launching. SpaceX is launching satellites of USA, where what used to be done by NASA, USA's aeronautical agency. So that work is also done by, they have outsourced it because it is able to launch in a cheaper manner. So this is the example of privatization. In USA, even defense is also privatized. Okay, many aspects are privatized in USA. It is working for them. So we are opening up the space sector. Why we are opening up the space sector? Because ISRO is working well. No doubt ISRO is working well. It has done the things in a much more cheaper manner, much more efficiency manner. Lot of things is done. Many advantages are there with ISRO. Then why we are opening up? The main reasons is if we boost private sector, employment will rise. More technology will come. Rather than, see, if you want, PSLV is created by ISRO long back. The technology is there. What ISRO is doing now, it is launching various satellites, KU band, CE band. The same repetitive task is done by ISRO. No? So once the technology is there, you give this technology, you outsource this to private people. And so that ISRO can only focus on research and development. That is the advantage. Competition will be higher in the market. People will be able to They may be able to manufacture our things in a much more cheaper cost in the future. Who knows? So these are the advantages if you enable privatization. Okay, so it's not that all the space Sriharikota can be launched for used for others. So in a year, Sriharikota will not be used every day. Na? Every day we are not launching a satellite. Suppose Ambani wants to launch a satellite, Ambani Sat. Now he will use space infrastructure and pay ISRO for that. Okay, suppose you want your name to be in the space like that. Data collection, many applications are there. Suppose the Adani company is there. Now these people became big shots. Lot of data is there on Adani companies. He want a special satellite for that to maintain all these communications and all this. So many people can open up and utilize this space activities. So in order to strengthen that, we have create so that ultimately ISRO can focus on research and development. It can focus on new technologies. Lot of things are there. 97% of the universe is called as dark matter. Dark in the sense we don't know what is it made up of. 97% of the universe almost. So a lot of things are there. New technologies, new exploration missions it can focus on. Human space flight it can focus on. Once we outsource the same thing. Okay, so that is the importance. So three things got created in space. Three agencies got created. In space, NSIL, and one previous thing was there called Anthrax. This was there in 1992 itself. These two are the new additions that we will see now. Okay, all the three we will see. The difference you have to understand so that a question can be addressed. So in space, full form of in space is Indian National Space Promotion and Authorization Center. Okay, this is a kind of a regulator for space sector. This is kind of a regulator for space sector. What do you mean by regulator? See, regulator means suppose you have telecom sector. Telecom sector, you have BSNL is there. Okay, and you have Geo, Airtel, varieties of things are there. Public government company is there, private company is there. What if they are doing some mischief, or they are what standards they have to maintain, what spectrums they have to maintain. All these things are regulated by a telecom regulatory authority. In fact, the name is TRAI, Telecom Regulatory Authority of India, to oversee the whole sector. So in that manner, like for stock market, we have SEBI. For capital markets, money market, SEBI is the regulator. For insurance, IRDA, Development Authority of India, like that. So for insurance sector. Like that, for every sector you have, in the same manner, for space sector, we created a regulator because we are privatizing it. Till now, there was no need because only ISRO was there. Once we privatize, many players will come into picture in order to make them follow rules. A new thing is there. So a level playing field, private sector and ISRO, both should compete in an equal manner, okay? And it will guide more private industry, it will support them. And it will also look at safety issue also. Because what if someone, Ambani or some rich fellow launched a satellite, but the satellite is not launched properly. It crashed onto Earth. Is it dangerous or not? Right? So that's the reason safety protocols have to be followed. In space will ensure that all these safety precautions are taken by private players also. So that is the role of in space. Next comes NSIL. NSIL, New Space India Limited. This is a company. Basically, it is like registered like a company. It has its own role. It will sell ISRO's assets to private people. It will make private people do their own satellite manufacture. Okay, so let us see the details of it. It's a public sector enterprise. It is created by the Government of India, New Space India Limited, like a public sector enterprise. Now, major business areas, production of it will produce PSLV, SSLV. What is SSLV? We will see now. Small satellite launch vehicle, we will see at the end. So all these vehicles can be produced by NSI because already the technology is there with ISRO. ISRO has this technology. Now it has outsourced to NSIL. NSIL will produce. Maybe it may ask some private papers also, private players also to produce. Now it will launch various services. It can get manufacturing of transponders. It can get remote sensing applications, various kind of mission support services. All these things can be supplied by NSIL. Like BHEL or like HAL, various government sector companies, they're doing various activities. Here also NSLL also will do with respect to space sector. So it will involve private people and all those things. It will build satellites, build launch vehicles, it will build satellites, it will sell the technology. It will sell the technology developed by ISRO to others, get a royalty like that. So various kinds of way, it's a kind of a good thing for privatization, and it will offer consultancy service also for various private sector, space sector activities. So it is registered under, as it a company, it should be registered under Companies Act, under Department of Space, Administrative Control. Still, it is a public sector company. It's not a private sector thing. Now, still, it is a public sector company which is helping for towards privatization of space. Okay, so InSpace is a regulator, NSIL is a company, which role we have seen. We have an old one called Antrix Corporation. Antrix is a minimum, see, the role of Antrix is like a commercial arm of ISRO. So ISRO has, for example, ISRO has created maps of Hyderabad, suppose. All these maps of Hyderabad, suppose you want to purchase these maps, that is done through Antrix, like that. Commercial arm of ISRO. It was there from long back, established in 1992 itself for commercially exploiting the space products of ISRO. Whatever ISRO applications are developing, that it will do. So there can be a mix with respect to Antrix and NSIL. Antrix, NSIL is a bigger version of Antrix. But they didn't, after creating NSIL, they didn't remove Antrix. This is also there now. Fine, but its activity is much more bigger. It also promotes ISRO products. It is given Mini Ratna. In economy, you will know Maharatna, Mini Ratna, Navaratna, all this status, okay, depending on the performance of companies. So these are the basic three differences between all the three bodies with respect to outsourcing of ISRO, privatization of space. Now write a question for today. You can write a question here. Why? Yeah, write a question here. Discuss the, or you can simply put critically analyze. Let us say critically analyze. I'll explain the difference here. Critically analyze government policy of privatization with respect to space sector. Critically analyze means you have to tell about positives, negatives, and way forward also. What is good in it, what is bad in it, and future suggestions. Critically analyze government policy of privatization with respect to space sector. Please note down this question. I'll correct all the questions, don't worry. Display Antrix 1. First write this question, I'll display Antrix. Okay, this is written. Yeah. This is Antrix. Okay. चले आगे. Right? Okay, madam. ठीक है. देखो. Write this question. Then this, after writing this question, this is one application which is launched by ISRO. The name of the satellite is Amazonia 1. PSLV is the C-51 is the launch vehicle. Name of the one important payload is Amazonia 1. Okay, this is launched to study Amazon forest. Where is Amazon forest? Brazil. To study about Amazon forest, very important for our environmental perspective. So new space, this is the first project dedicated, important. Why it is important? Because we have outsourced. See, why India is launching about Amazon? Because they have asked us, they will pay us. That job is done by NSIL to get players. So not only in India, NSIL will serve to private countries of other needs. Okay, other countries' needs also. So this is the first dedicated commercial mission of New Space India Limited. That's the reason it is important. So it will study about Amazon region, how agriculture in Brazil, how it is being impacted, how deforestation is affected. All that mapping will be done by this Amazonia one. So people paid Indian ISRO through NSI. That's the reason. This is see how we are outsourcing. Once privatization kicks in, many people will use our services and pay us. Okay, like GPS, our country is paying for the GPS of ISRO, GPS of USA. So now India develops these things. It will also be selling many things to various things, kind of. So in Satish Dhawan Space Center, anyway, this photo is said. How many launching pads are there in our satellite launch station, SHAR? How many launch pads are there? Anyone? We are launching our satellites through Sriharikota, right? How many launch pads are there? Two. Two are there. This is one. I just remembered. Another is this. Two launch pads we'll have on from which we will be launching various satellites. Okay. One more in progress to build. Okay, let's see. As of now, two. Fine, Narsimlo. Now, coming back here. Yeah. Human space flight we will do in Gaganyaan in more detail. Chandrayaan and Gaganyaan, all these three missions, we will Mangalyaan, we will do in detail later. Human space is flight is possible when you have re-entry. Anyway, GSLV Mark 3 will be used. Don't go by all the things here. We discussed about human space, why it is done, why it is not done till now. All these things we saw. Experimental stage. Anyway, they are trying to. Gaganyaan will have details. Very recent development is SSLV. Small satellite launch vehicle. You have PSLV. You have GSLV. Now the next thing, new terminology is small satellite launch vehicle. Okay, the importance of the small satellite launch vehicle is, and again, NSCL is involved. New Space India Limited is involved in its development. Look at the mark here, New Space India Limited. Okay, so rather than building, like the name says, small satellite launch vehicle, rather than see, PSLV, it can launch even 100 satellites also. But what if I want to launch only 3 or 4 satellites, that too small satellites? Again, you have to build that PSLV, lot of cost. So in order to avoid that, ISRO has created it, compact launcher. It is a mini version of PSLV kind of thing, compact launcher. So more cost effective, dedicated things. So it is using all solid vehicle. That is the importance. No liquid fuel stage is there in SSLV. 3-stage all solid vehicles. Okay, for sun synchronous orbit. So it's a miniature version of PSLV. But no liquid stage here, no 4 stages, only 3 solid stages are there. So varieties of satellites are there, nano satellite, micro satellite, small satellites, depending on their weight, which we will see. So the specialty is, as this is for miniature version, it can be assembled in 3 days. PSLV needs 60 days for assembling. So very quickly we can launch. Now once PSLV is launched, for next 60 days we have to wait. So very quickly we can launch all these smaller satellites with small satellite launch vehicle up to 500 kilometers in low Earth orbits. Okay, so this is the things. These are some of the things. We will see many things now. China space missions, or why are you interested in China space mission? It's not that we are following every space mission of China. Some important things are there. China is planning its own space station. Okay, its own space station. We have international space station, collaboration of various countries. India is not there directly in it. Indirectly only it is there. Fine. We have International Space Station, which is roaming around the Earth. Astronauts are there now. China is building its own space station. The name of that station is Tanhe or Harmony of the Heavens. So Harmony of the Heavens recently seen in news because they want to target it by this year end. Harmony of Heavens recently seen in news is related to China's own space station. Like that, you have to answer. Don't write Harmony of Heavens is a kind of a new music album or a new this thing, some project with respect to environment. Okay. So like that, Harmony of Heavens. That is one important thing. As I said, International Space Station already is there. It is built by few countries collaboration. India is supporting indirectly only, but mainly the countries involved are Russia, Europe, Japan, and Canada. In ISS, China is not there. India is also not there. So this Europe, in the sense, European Space Agency. Whole Europe has a single like that European Space Agency. All the countries of Europe, mostly all the countries of Europe, like this. So ISS, which of this can be also prelims question, PT. Okay, who of the following are ISS is backed by which of the following, like that. Okay. So one more important thing is there with respect to moon. If you observe our moon, our beautiful moon, here you have Earth, suppose, then you have moon here. Moon always, you will feel as if only one mark is there. Some people say that a tree is there and a old lady is sitting. Like that mark only will be there. Or someone will say that this looks like a rabbit. So we are not seeing the other side of the moon. We are not looking at far side of the moon. It is not visible for us. Anywhere you go, not only in India. Wherever you go, far side of the moon is not visible because the rotation and revolution of Earth and moon are matching. So we are only seeing one side of the moon always, whether it is shrinking or not, whether it is going like this, always one side of the moon only we will see. So no one has launched a mission on the other side of the moon. First one to do that was world's first landing, lunar landing on other side or far side of the moon is done by China. That is very important. Okay. So that is the specialty. Only this. Many missions are there with respect to China. China is going ahead with many big space missions. Leave all those things. This aspect is important. It is the first country to launch a mission on far side of the moon. It was able to send like that. So some terms I will introduce today. So before exploring the space, we need to know these things. Dwarf planet. Okay, what are dwarf? These are all PT pointers. So what is a dwarf planet? See, why Pluto is not a planet? Because it is a rocky thing, it is small object, and it does not have a single orbit. Its orbit will change. So whatever may be the reasons, we fix it. It is not, Earth is going in a fixed orbit. Pluto is not going in that orbit. It changes. Sometimes it will be 8th planet. Sometimes it used to be 9th planet from the sun. So we removed Pluto. So that Navagraha concept is not there now, for as far as space is concerned. Technically speaking, Pluto is not a planet. Okay, so there's another term called dwarf planet. What is a dwarf planet? There are many objects in the solar system. It's not only solar system has only sun and planets. You have asteroids, you have comets, you have varieties of things. So one such thing we have identifying dwarf planet. Other than the natural satellite, dwarf planet means which orbits around the sun and smaller than Mercury. If a planet is there, which is small, if an object, not a planet, if an object is there in the solar system, which is smaller than Mercury. So that is called as a dwarf planet. Okay. Now it said that designating Pluto after Pluto. Pluto is also part of this dwarf planets. These are various dwarf planets we have. Eris, Pluto, Hume, Make, Ceres. Okay, if these objects are away from Pluto, this is sun. Pluto is somewhere here. If they are outside this also, then they are again given a new term, which are called as Plutoids. That's what we will see here in this thing. Okay, like this here, dwarf planets which are farther from Sun than Neptune, not Pluto here, sorry, which are farther from Neptune. After Neptune, if you have these dwarf planets, they are called as Plutoids. Fine. So Cirrus is not a Plutoid because Cirrus will stay in asteroid belt. Where is the asteroid belt? Between Mars and Jupiter. Okay, so in that asteroid belt, we have a dwarf planet called Cirrus. All dwarf planets are away from Neptune or near to Pluto. That's the reason they are called as Plutoids. Okay, so Plutoids seen in the news are what? Plutoids seen in the news are what? A. Satellites of Pluto. Satellites of Pluto. B. A question option will be there. A, B, B. Dwarf planet. Like that. Some options will be given. You have to take. Plutoids are nothing but dwarf planets. Okay. Like that. Fine. Then we will go to some terminology here. See, am I overloading you with many things? Are you able to understand or not? Yes or no? Yes. Okay. So this is what required. We have to do in intense manner. No? It's a small group. We will do as much as possible. So here, planets, heard about planets. You heard about planets. Exoplanets means planets which are outside the solar system. How can we say that in only solar system, sun will be there? There are around it planets. There are millions of stars in the soul in the universe. Around them also raw planets will be rotating. Whether life is there in them is a question. Whether aliens are there, that those are all for movies. We don't know. Still we are exploring. Okay. In fact, there is a theory which says that, like we will see in NCRT maybe, which says that we ourselves are aliens on this planet. Because how life originated in this planet, till now there is no proof. How life, see, if we have a man is there or a organism is there, we know the chemical composition of it. 10 kilos of carbon, 5 kilos of nitrogen. If you look the body content and if you give it in the lab, can they create life? No, they can't create even a bacteria also. So how life originated, there is no guarantee. There is some theories which say that the meteors which are there, they brought life to Earth volcano. So what is the first life form? Anyone? What is the first life form? As far as the present theories is there, life originated in all these there are in NCRTs. What is the first life form? Life form. Yeah, what blue-green algae. Okay, it all started with a unicellular blue-green algae. From that only everything started. Fine. So exoplanets, there are many exoplanets, rocky kind of things which got discovered in the solar system, which are called as exoplanet. Stars, Stars, planets, What is the difference between stars and planets? Stars have nuclear fusion reaction. The sun is able to burn because there is a reaction going on here in the sun, hydrogen plus hydrogen giving to helium. That is the reason it is able to burn. Okay, hydrogen plus hydrogen giving to helium. This kind of reaction is called fusion reaction, nuclear fusion reaction. We will see them in detail. What is fusion? What is fission? We will see in detail in energy class. So every star is made up of this fusion reaction only. If this fuel is over, the star will go through various stages, black hole, supernova, and all those things. Okay, so stars is one extreme, planets is one extreme. In between, you have brown dwarfs. Don't get confused with dwarf planet, which we saw yesterday in the last slide. Brown dwarfs are neither a star nor a planet. The star in between, when the star is almost ready to collapse, it is not collapsing completely. It is not a planet altogether. Then it will become what? Brown dwarf. Okay, in between planets and stars, you have what? Brown dwarf. It have both rocks also. It has both these reactions also, which are fading away. So both are there. That's the reason they will exhibit different colors, right? Then a very interesting phenomena is observed called gravitation lensing. What is gravitation lensing here is, see, what is a lens? Let us take here. What is a lens here? There's a lens here. Hmm. See, we are not doing physics here again. I'm be conscious about that. And suppose there is a candle here. Now, light will come from the candle. You are here, sitting, wearing your spectacles and watching. Now, light will come from here. It will bend. Okay. It will come here and it will bend from down also, whatever. Now, if you see here, this light is reaching as you. It is reaching. You are observing with your eyes here. You will feel that as if because of this bending, this candle is here. Okay, the lens has bent it. This has bent this rays here. Okay, because of that, you will see as if your light, your source of light, candle or whatever, is somewhere here, but actually it is here. So this kind of bending is possible in the universe, where gravity will act like a lens and bend the light. So if you see in this diagram, if you see, this is Earth actually. It is being here cut here. This is Earth. You are observing various galaxies. All these are galaxies. You are observing all these galaxies. Okay, the galaxies are emitting lot of light. Now there is lot of gravity here. This is acting like a big lens, and it is bending the light. It is bending the light. So the galaxy, now you are Earth, there is a galaxy here, big spiral galaxy here. Because of the gravity, the light from which is reaching us from this galaxy is being bent. Now you are observing from Earth, you will feel as if the galaxy is somewhere else. It will look as if it is somewhere else. The body, all the stars are acting like a lens and they are bending. The galaxy will appear to you as if it is located here, but actually it is not located there. So this phenomena is called as gravitational lensing. Okay, objects distorted. We can't bend the light. We can't see the galaxy position clearly, star position, everything will be different. So what we may feel, which we are looking, that may not be a reality. Okay, now one more topic we will do, theme, sun's corona. Don't log that, this is corona. Huh? Forget about our coronavirus. Previously itself, there is a phenomena called sun's corona. What is the speciality of this sun is, sun is burning, lot of fuel, I said. Yes or no? All the data, see, is there, light bends when it enters a denser or rarer, vice versa. Here, which is, sir, which is denser? No, that is bending, that is reflection, refraction, that is different, my dear. The bending here, the light can also bend if there is a strong, like if that is a important discovery we got now. See, what is being happening is the gravity, all the stars here are having exerting so much of pressure, so much of pull they are even bending light. Like black hole will suck light, it can't allow light also. In the same manner, all the galaxies are acting like a bigger mass and they are bending light also. So it is not density thing here. Okay, so that is a extra impact of this, all these cluster galaxies which are acting like a lens. Okay, clear? The person who has asked the doubt, Biswas, samajh mein aaya? There is no medium here, don't confuse with the medium. Okay, very good. Now sun's corona, see about sun's corona. What is sun's corona is very interesting thing. There is no answer till now for this phenomena. Sun is there, surface temperature of the sun is around 6,000 degrees centigrade. Surface temperature on the sun is around 6,000 degrees centigrade. Sir, how do you know? Did you go there? No, they are instruments. They are instruments which are there. Just me complete it, then I can show the other slide. Okay, they are instruments through which we measure radiation and all those things. Now, what is happening here is, as we hear, just above the surface of the sun, for a few hundred kilometers, the temperature is very much higher. than the surface of the sun. As we go away, temperature should decrease, na? But just above the surface of the sun, for a few hundred kilometers, the temperature is becoming 100 times more temperature. Why the sun is having this much of high temperature above on its surface? Till now, there is no answer. We are unable to have. Because of this high temp, that reason is called corona. Because of this high temperature only, solar winds are being get. The sun will release lot of radiation because of this high temperature. Charges are released. It's only that Earth has a magnetic field protecting us from all these radiations. So Earth is protected in multiple ways. Okay. So in this manner, we are having why the sun is having this much of high temperature. Till now, the science has no answer. So that is the speciality of sun's corona. Okay, on the sun's atmosphere, outer atmosphere. More temperature you have. Corona is using a total. Of course, we can view corona during solar eclipse. Those are these things we have. The high temperatures of corona, just underline or note down the highlighted points. Corona's high temperature is a bit a mystery. We don't know why it is still there. No explanation till now. Okay. Hundreds of times, as I explained, corona is 100 times more hotter than sun's surface. Hundreds of times more hotter. Fine. So this is the thing. And yeah, you want the previous slide, right? Yeah. See this gravitational lensing. All this data is not required, leave it. See only this gravitational lensing. This is Earth. This is galaxies bending of the light rays. Okay. Fine. So that's it for today. We did all these things. Small satellite launch vehicle, PSLVs, antrics, privatization in space. One question also I gave. Reforms in space sector. Like this, we are going air breathing portion, space capsule, recovery. Okay. Yeah, I'll share the slides. Don't worry. I'll put these slides and I'll save them and put it. Now, how is the speed? Later, do we have time for the next class? Don't worry, it's almost 9. Is the speed okay? Because I want to cover as many things for you as possible. Yeah, very good. Fine. So we'll not open these sessions. Maybe I'm expecting another 10 students. Can you reduce the speed? Because more try to revise, because were you there, Krishna Priya, in the previous classes? Revision is important, then only you can catch up the things. Let's see how it works out. In between only we'll have some open sessions. When space is done, then we'll close. In defense, then we will have 1 or 2 open sessions, like the topic by topic we will go. So tomorrow there won't be any class, and you revise these things, and jet speed like वकील साहब sir. क्या करें मैडम, हम तो बहुत we have to cover a lot. चलेंगे. Yes, recorded videos, they are recording it. But try to concentrate. 1 or 2 things if you miss, you can, because again you listen to these things, it is time waste. They will attach to the email ID with which you are provided, and based on that, they will. Generally, we will have sessions, extended sessions on Sundays also. But let the settle out. There are many people, if not many, at least how many are there? At least other half still want to join. So after some step, it gets stabilized, we will have sessions on Sunday also. Tomorrow there may be some NCRT sessions. Sir will inform. So for tomorrow only, we will not have SNT session. Sunday also no class this time. We will start again on Monday for this time. Okay. Chalo all. Bye bye. Take care. Good night. Good night. Bye bye.